Professor Lyrigis is going to moderate this panel. Could you please take your place here at the podium? You are mostly welcome. Yannis, you are undertaking moderation.
Thank you. Yes, my talk actually is later, so I would like to start saying that that is once more a successful conference organized and initiated by Tonia Moropoulou, and indeed it's a very useful and much wanted information and event nowadays in Greece. I thank you, Tonia Moropoulou, for inviting me to moderate this panel entitled Archaeometry and Archaeogene, Testimony of Monument History, a special honorary session in memoriam of our dear colleague and friend Nikos Zacharias. First of all, I would like to invite three speakers, Dr. Vasilis Kilikoglou, Maria Kilafi, and Tonia Moropoulou, to present the academic work, The Profile and Values of Unforgettable Late Colleague and Dearest Friend, Professor Nikos Zacharias. I start inviting Dr. Vasilis Kilikoglou to the podium. Vasilis, you can start.
Πού είναι το... Την παρουσίαση του κυρίου Κιλικόγλου.
Σωστά. Καλησπέρα. Good evening, everybody. Just to say a few words about our very dear friend and colleague, Nikos Zacharias, on the memory of whom this session is dedicated. I come from the National Center for Scientific Research, Dimoktos, where Nikos Zacharias did his PhD and the first years of his postdoctoral career. So I'm very, very happy to say just a few words for the next 5 minutes. The subtitle is The Human Face of Archaeological Science, because I think the main characteristic of Nikos is the human character of himself. Okay, if I wanted to characterize him with one word, I would say he was human. Nikos had a very remarkable career, a very remarkable development of his career, and because I have been following him from his first steps, I thought I can just give you a very brief description of what he did. He started, if this is the time is down here, and scientific field is on the vertical axis. I can put thermoluminescence dating as his first, I'd say, step. That was his PhD. He did at Dimoktos. And I think the development shows his character. The second step was the work on luminescence dating, optically stimulated luminescence dating. So he expanded the field of luminescence, from thermoluminescence to luminescence. And then he moved to ceramic provenance by joining in a European project at Dimoktos and working in Bonn, in Germany, for more than a year. Then after that, he moved into glass technology and provenance, where his work was remarkable. After that, or parallel to that, geoarchaeology, digital tools. That was the his recent thing. So altogether, we see a progress with time which was linear, And in my opinion, it would be exponential if we hadn't lost him almost a year ago, or more than a year ago. Here I summarized, I give the titles of just a few papers of his, just to show a few things of the first steps of his career. He started, as I told you, up there with the luminescence, thermoluminescence dating. Then he started working on luminescence and dating of lime. Then he did the neutron activation of ceramics for provenance. Then he combined all these things and started studying the effect of alteration and the effect of alterations in the dating of ceramics. So even from the first steps, he was a person, he was trying to develop and join things, bringing people together, and for the benefit of the field, I would say. And I want to finish with just a few photographs of this very many years ago, 25 years ago. This is Nikos here in a European project, in a meeting of a European project we had in England. Then in a conference, smoking his cigarette, along with friends and colleagues. And that shows his social character, organizing visits at wineries, etc. And this is the most recent photo I have of him, as with very close friends, and me and Nikos on the right, with this characteristic smile on his face, where always reminds me the Alice in Wonderland, where it says the cat disappears gradually until nothing is left but it's green. At Nikos' case, we could say it disappears gradually until nothing is left but his smile and his legacy. Thank you.
Ευχαριστούμε, Βασίλη. Είναι emotional το θέμα και σίγουρα δεν είναι εύκολο να πει κανείς λόγια παρά μόνο να μείνει silent και να σκέφτονται το φίλο μας. Να δώσω το λόγο στον επόμενο μιλητή, την Μαρία Κιλάφη, παρακαλώ.
Την παρουσίαση της κυρίας Κιλάφη.
Good evening, dear colleagues and professors and scholars. I would like to express my gratitude, first of all, to Professor Moropoulou for her invitation and dedicating this panel in memoriam of Professor Nikos Zacharias. And it's an honor also for me being here today in this panel with all the colleagues and with whom Nikos worked closely for many years. I work as an archaeologist in the Ministry of Culture and for the last 14 years. I've been in the FR8 of Messina, and being married to Professor Zacharias, I discovered archaeometry very early. Actually, it was when he was doing his master's, at Democritus, and I must say that I was actually, what impressed me was that word Democritus. And that's because for me it was a magical word, and imagining all that things that were going on in there. I mean, after Nikos completing his studies, and you can see how, some of it in the slide page. At being a senior researcher of the Laboratory of Archaeometry in Democritus, he resigned in 2009 and accepted the position in the University of the Peloponnese as an assistant professor and later on full professor, and of course as a director of the Laboratory of Archaeometry. He resigned because he was challenged by the opportunity to develop the Laboratory of Archaeometry and establish it within the global scientific community. A goal that he surely achieved through hard work, dedication, innovation, creativity, enthusiasm, and the wildness to embrace new ideas. The relocation of the whole family to Kalamata surely played a significant role in this development, and it's something that he kept saying. Some of his achievements are shown in the slide page, and we could stand out some of them. His innovation of dating mortars and plasters with OSL technique, and he was the first that did it, a technique that was applied for dating mortar of the tomb in Jerusalem, as Professor Moropoulou will tell us later. And he was the founder of many conferences and awards, as the Costa Navarino International Archaeometry Award. He implemented a lot of projects, such as the Emblematic program, Kalamata 1821, Roads of Freedom, for creativity and the publicity it has received. The Mokaku project was also an innovating program for maintenance and protection of mainly portable icons and other ecclesiastic objects in the Kalamata and Kalavritis in Ioannina. Of course, I will not miss mentioning the geo-archaeological program of Pylos. I remember that we kept talking about it from 2014, and we actually managed to conduct it in 2021. It is conducted along the west coastline of Messenia, in the area of Voidokilia, north of Pylos, and the area is of great historical, archaeological, and environmental importance. And it is an example, the project is an example of interdisciplinary method using innovative scientific methodologies in a range of different fields, and collaborate with specialists such as conservators, civil engineers, archaeologists, geologists, that are required for the better understanding of the data. Very important are the education programs carried out in the area in cooperation with the Captain Vasilis at Carmen Konstantakopoulos Foundation, a program which is still in progress, and of course we continue our collaboration with the laboratory and Professor Eleni Zimi, the new director of the laboratory, after the unexpected death of Nikos. And of course, another important program just started, and we're looking forward to work for it, the Evlogon. Professor Nikos Zacharias was always optimistic, enthusiastic, and he believed in collaboration, in synergies, in extroversion and diffusion of the knowledge in society, and he had been working in this direction. In this point, I wanted to share some thoughts with you. It's been a year from his death, and it's difficult to gather and compress a man's life, a man that was so vivid and so full of ideas and energy, and compress it and put it in a box, in a shelf, in a page. But as Nikos used to say, life goes on, and he kept moving. And so we should do the same, and keep in mind that he always said that culture accommodates all expertise, and may his spirit be alive. And Alice Monitos, as Professor Moropoulou said in the 8th symposium that was held in Kalamata just a few months ago. Thank you.
Thank you, Maria. May I invite Dr. Tonia Moropoulou?
Thank you, Professor Lyrigis. My presentation, please, can you upload? It is indeed as if we were 2 years ago at the 3rd TMM-CH conference when Nikos was here at this panel. And I think it is like yesterday. But as we say at my home in Rhodes, he is unforgettable, Alice Monitos. He was a student, my student at the School of Chemical Engineering at the National Technical University of Athens. He became a scientific collaborator, a researcher, a friend, then a scholar. Then he opened horizons in which we were acting together. I'm just going very briefly to show some of his achievements, which enriched our common work in very, very important projects. Here, working on Hagia Sophia mosaics, when we were working in Istanbul, Constantinople, on Hagia Sophia mosaics preservation. These are some of the tessera we examined, green, red, blue, black, and some golden and silver as well, through a methodology of combined experimental techniques, prompt gamma activation analysis, fiber optics microscopy, scanning electron microscopy coupled with an energy dispersion analyzer, X-rays, fluorescence, and through all this, he was capable with our common team to investigate the technology of historic glass comprising this tessera, and to assign this technology to proper historic periods. And that was very important concerning the Hagia Sophia conservation strategy of the mosaics, because we had in different periods the original Byzantine tessera from the Justinian Hagia Sophia, which he actually identified. We had the later Byzantine, in later restoration periods, tessera, and then the one of the 15th century. I mean, we had the 6th century, the 10th century, and the 14th century, and then later interventions. And he actually identified through a combined analysis the prevalence, the technology of the glass tessera, and that permitted us to define our preservation strategy. And furthermore, he performed the PCA analysis according to St. Procodemus and the Achyrropytos Thessaloniki tessera in order to finally conclude for the historical periods, and that was really a basic work for Hagia Sophia. Furthermore, in the Holy Edicule rehabilitation, and especially when we opened the Tomb of Christ, he was definitely involved, and his work with luminescence dating results, optically stimulated luminescence, performed towards the archaeometric investigation of the different types of mortars, which were the ones we took. The sampling was after the opening of the tomb, under the most ancient grey slab, and the answer was that this slab was put there by Constantine the Great at his era. Around the Tomb of Christ, of course, he identified the Constantine Monomachos restoration at the 11th century, the Bonifacio di Ragusa Renaissance restoration at 16th century, and furthermore, he even discovered, he even discovered the Komninos Mytilineos era at the early 19th century. This was in agreement with the archaeogenomic work on the microbiota characterization, and it was definitely the most important historic approach to our findings. We had even at the Catholicon of Panagia Varnakova, which was completed August 24, but when we started, he gave a hand to actually define in pronaos the original builded masonries at the 11th century, when was the original period of construction of Catholicon. And that was a very important push over to the strategy that the ephoriate of Phokis planned with us hand by hand for the preservation of the Varnakova monastery. I won't go further because these are historical achievements. I will only say that the project Evlogon, which is now involving the University of Peloponnese, the Laboratory of Archaeometry, is continuing this work and is going to the horizons he opened to give the presence of his work and of his successors. And this merging of different competencies, the chemical engineering, archaeology, archaeometry, are really critical for the future. And we will always feel that Nikos is here. Thank you very much.
Thank you, Tonya. Thank you, Tonya. It is so well obvious, seeing, the multidimensional character of our Nikos in every direction of and branch of archaeometry, archaeological sciences. I would like now to continue our next speaker. I think is myself. So if you could please upload my PPT, if it is possible. Well, this is a brief introduction to the subject of toward the bioscientific archaeology of monuments. Next, please. Traditional archaeology so far often isolates the physical structure from biological context, leading to incomplete, of course, narratives. The integration of or coupling of STEM in arts and culture or archaeometry and archaeogene testimony marks a paradigm shift in monument studies. Those domains, while distinct in methods, converge in purpose, revealing the full biography of monuments, not just when and how they were built, but also by whom, for what purpose, and within which environmental and social ecosystems. Archaeogene testimony refers to the genetic and biomolecular evidence that contributes to our understanding of monument history and may include, for example, ancient DNA analysis of human remains found or in near monument, isotopic studies including strontium, oxygen, carbon trace geographical origins, migration patterns, diets of populations, and also microbiome and residue analysis from surfaces, tools, or burial codex to detect usage and interaction with biological materials. Next, please. Regarding the conceptual foundations of the coupling, this coupling occurs when finding from each field findings that are brought into dialogue. From one side, we have the aspects, discipline, primary focus, and output, and then the archaeometry, the archaeogene testimony that provide a coupled interpretation. Next, please. The methodological integration and how it works. This works through the chronological synchronization, first one. Example, a tomb, beneath a table could be dated to 3200 BC. Via thermoluminescence contains remains genetically linked to a population that arrived in the region around, say, 3300 BC via genome-wide sequencing. The table's construction coincides with a known migration event. This is an example. Also, we have the provenance matching. This may imply that the labor force may have orientated near the quarry or suggesting mobile construction crews tied to the resource zone. Also, biocultural activity analysis, residue analysis, and genetic comparison. For example, sacrificial animals may carry genetic markers from a distant region indicating trade or ritual pilgrimage. And environmental contextualizations, including pollen analysis, sediment cores, mineralogy, and epigenetic markers. For example, a monument built during a drought, confirmed by sediment cores, may show high child mortality in associated graves. A combined analysis reveals the monument may be a site of ritualized response to climatic change. Next one, please. An example among several is the Stonehenge. With archaeometry, for example, petrological studies have revealed the origin of the blue stones from Wales, around 200 kilometers away, radiocarbon of post holes and Adler peaks used in construction, and OSL of surrounding hearths and cremation remains refines usage periods of between 3000 to 1600 BC. Environmental reconstruction of pollen and sediment cores revealed gradual transition from woodland to open grassland, suggesting large-scale modification linked to the ritual activity. With archaeogene testimony, genetic analysis of nearby burials indicate a mixture of Neolithic and Beaker cultures individuals, showing migration waves tied to the monument use. Also diet and lifestyle with carbon and nitrogen isotopes, which indicated mixed agricultural diet, and in some individuals, some marine food signals implying regional variation or pilgrimage. And moreover, epigenetic markers which suggest chronic stress and nutritional shifts aligning with broader changes in climate or social organization during the late Neolithic. Next one, please. Regarding now the challenges and the ethical dimensions of this coupling, the three issues must be considered. First, the data compatibility. Different preservation conditions mean genetic material and structural materials may not coexist in good condition. The chronological discrepancies, human, for example, remains may post-date structures, complicating assumptions of original use, and ethical concerns. For example, sampling of human remains raises questions of cultural sensitivity and consent from descendant communities. What is the solution for this? Must we have integrative frameworks? Must be the ethical, the collaborative, and transparent, especially in post-colonial and indigenous context. Next one, please. Next one. The coupling of archaeometry and archaeogene testimony invites a shift from static to dynamic interpretations. Monuments are not merely fixed artifacts. They are nodes in human environment interaction network. And construction, use, abandonment, and memory are all part of a monument's life history. And the last one, in conclusion, in conclusion, I could say that the fusion of archaeometry's material insights and archaeogene testimony human stories represent one of the most promising frontiers in archaeology. Through the interdisciplinarity, our understanding of monuments will become not only more accurate, but more human. Through this coupling, the stones speak, and we hear both the builders and the ancestors' voices echo across the time. Thank you for your attention. And now we have to move to the next speaker, because time has been short. It is Dr. Agelakopoulou Irini from the Acropolis Restoration Service, Technical Office and Surface Conservation Laboratory, and head in National Technical University of Athens Interdisciplinary Team for Emblematic Monuments.
Can you hear me, ladies and gentlemen? Good afternoon from me. Maybe I have to... Okay, good afternoon from me. Okay, I see the... Just a moment. Maybe I must use... Okay, thank you. Okay, μετά αυτό.
Το κεντρικό αλλάζει.
Δεν αλλάζει, γιατί? Το μεγάλο πατάω.
Ναι, σωστά.
Το μεγάλο κουμπάκι πατήστε. Το μεγάλο.
Το μεγάλο πατάω, αλλά... Είναι προηγμένη τεχνολογία, αλλά όχι τόσο προηγμένη. Εντάξει, να κάνω έτσι.
Τίποτα, μήπως κόλλησε. Τώρα δουλεύει αυτό.
Τώρα δουλεύει αυτό.
Ναι.
Εντάξει.
Όχι, αυτό το back, το από πάνω. Μπράβο.
Εντάξει. Ladies and gentlemen, good afternoon from me. I'm Eleni Angelakopoulou. It's an honor of me to be here in this panel that is in memoriam of Nikos Zacharias, which I knew him in person through mainly our research activities. And this that I can say for Nikos is that except that he was a great scientist with an exceptional work, that we all know it, he was a very pleasant and modest and easygoing person that always wants to cooperate with others and with the new researchers. And the last time I saw him here, and he was so open that you should come to Kalamata and see what we do now and to find a common activity together. So it's an honor to be here, and I would like to, my contribution to this panel is to present how the archaeometry and the archaeometric investigation, that it was the main discipline of Nikos Zacharias, can be used in order to reveal new production technologies of monuments. And I will speak for two monuments. The first is the Acropolis and the reveal of the polychromy of the Acropolis monuments. This is a project that is conducted by the Acropolis Restoration Service. And the second one is, of course, the production technology of the Holy Edicules historic mortars that is conducted by National Technical University of Athens. And I have the honor and the pleasure to participate in the interdisciplinary team together with Professor Moropoulou. Regarding the Parthenon's polychromy, although we know from 19th century that the Parthenon and all the ancient temples were full of colors, because at that point many scholars and travelers visited Athens, and they studied the complexity of the ancient architecture, and under this framework they produced a large amount of texts and color representations of how the Parthenon and the other monuments looked like with colors. But although we have so many texts and so many color representations, as you can see here, where I have three representations, there is a great discrepancy between the representations, and we can say that we have a rather confused image how the Parthenon really looked like during the antiquity. So this work, this research, the scopus of this research is to reveal the polychromy of the Parthenon based on the scientific results that we take through archaeometric investigation. The first step that we do is to do many imaging and non-invasive techniques that are applied in situ. And here is a characteristic image where we have, okay, I don't know, here in this area, no, maybe, where can I see it? Okay, there is no indication, I will speak. Το πάνω κουμπάκι, το πάνω, δεν λειτουργεί και αυτό. Εντάξει. Where we have the raking schema that decorates the corner of the Parthenon, and in the large photo we can see nothing on the marble surface, But with using visible induced luminescence imaging, we managed to find the whole pattern that is consisted with anthemia and lotus blossoms, as we can see here, that corresponds to something like that. Except the imaging and the non-invasive techniques, we used many laboratory techniques that are applied on microsamples that were taken for the monument. As you can see here, different microscopies, semi-DX analysis, ATR, FTIR spectroscopy, micro-Raman spectroscopy, and we succeeded to determine what the pigments were. And the results of this research still now is that in some cases, like the cornice blocks and the metopes, we know what the patterns were used and where the colors looked like. And we found the whole palette of that ancient painters used. 2 blue pigments, azurite and Egyptian blue, 3 red pigments, 1 green pigment, conihalkite that has arsenic inside, and 1 black pigment. Another thing that it was interesting is that we succeeded to determine the beeswax that was present on the paint layers through different spectroscopies, as we can see here. And this was important because we know from the inscriptions that were buried outside the Erechtheion how much the encosters, the technicians that painted the Erechtheion, were paid. And now we have the scientific proof that this is bonded together. So the inscriptions the ancient inscriptions found after 2,500 years, the scientific proof that the beeswax was the binder of the paint layers of the Acropolis monuments. We also did a collaboration with the University of Bristol in order to determine the age of beeswax. This project is in progress, and we are in the final step to write this research work. Of course, we have many things to do in the future, better digital representations, and to study also the provenance of pigments, to define the quarries, to decode the trading routes, and to make a new narrative about this. The second monument is the Holy Edicule in Jerusalem and the study of the historic mortars. During this gorgeous and emblematic interdisciplinary work, mortar samples were taken and they were studied. And we had a collaboration of NTUA and the University of Peloponnese, and Nikos Zacharias himself, as Professor Moropoulou told it before, where they combined the dating results taken by optically stimulated luminescence with other techniques. And with this study, 4 distinct chronological periods were determined of the 4th century, 11th century, 16th century, and 19th century. And now we are in the progress and in evolution to learn more about the production technology of these mortars. So we use more laboratory techniques, and we would like to determine the mixing ratio of binder to aggregates, the grain size distribution of aggregates, and the nature of binder at aggregates. We're talking about gypsum mortars that are the characteristic of Middle East. And through this research we will define some peculiarities that these mortars have, like the presence of edricite inside some aggregates, etc. And all this will be connected with the dating results, of course, and in order to elucidate the construction history of the top chamber. As a conclusion, I would say that the archaeometry investigation, when is coupled with historical testimonies, literature references, archaeological, architectural, environmental data analysis, the monument history is enhanced and a new, much more interesting narrative is created. Thank you very much.
Thank you. Thank you, Eleni. very concise and to the point your presentation. Thank you. I would like now to invite to the podium the next speaker, Eleni Zimi, Associate Professor in the University of Peloponnese.
Dear colleagues, I'm addressing you today here as the new director of the Laboratory of Archaeometry in Kalamata. I have been deeply honored and privileged to be entrusted with this responsibility as a successor of our esteemed colleague, Nikos Zacharias, whose untimely death left a huge gap in our hearts and in our department. Nikos' vision was exceptional and his legacy in archaeometry most valuable. Nikos Zacharias endowed the Department of History, Archaeology and Cultural Resources Management of the University of the Peloponnese with a very well-organized and competitive lab in terms of infrastructure and equipment, in terms of remarkable young scientists and researchers, numbering over 15, and with a broad network of collaborators. The Laboratory of Archaeology has a long history. It was founded in 2007. Since then, it has been active in applying state-of-the-art techniques with an emphasis on the non-destructive methods to analyze cultural heritage materials, to support the teaching of archaeology, of archaeometry in undergraduate and graduate level, and to publish the research results in well-established scientific journals. Within the past decade, a lot has been achieved by our lab towards several scientific fronts, including absolute dating of archaeomaterials, paleoenvironmental studies, remote sensing and GIS in landscape archaeology, and 3D reconstructions of ancient artifacts and monuments. As an archaeologist myself, I have always appreciated and valued the interaction between archaeology and archaeometry. The techniques and approaches from natural sciences provide archaeology with empirical and systematic ways of collecting, analyzing, and interpreting data related to the material record of human history. Archaeometric techniques are fundamentally important to archaeological research. They reveal the varied ways in which humans engage with the material world and the range of earth processes that are involved in this relationship. Among various projects, the Laboratory of Archaeometry had the privilege to actively participate in two emblematic research programs, as mentioned by Professor Moropoulou. One related to the Byzantine Church of Hagia Sophia in Constantinople, and the second to the tomb chamber of the Holy Edicule of the Holy Sepulchre in Jerusalem. In the former program, a number of gold mosaic tesserae were analyzed in our lab, pointing to important results about technology and circulation of materials in the Byzantine Empire. In the latter, the lab focused in mortar analysis, which updated the different chronological phases of the tomb chamber. Furthermore, through this work, the students and researchers of our lab developed the solid background and expertise required to contribute further to new research and open new paths in science. As members of the Archaeometry Lab and building upon Nikos Zacharias' legacy, we are working to consolidate and continue the excellent hands-on research in archaeometry, to readdress the importance of interdisciplinary studies in tracing the history of material culture, and the significance of archaeometry in particular for learning about the use and the tear and wear of ancient monuments and artifacts. And most importantly, to transform this knowledge to practice and contribute towards the physical and digital preservation of our material culture for future generations with the use of cutting-edge technology. In the present of rebooting, we feel indeed very grateful and proud to have been invited to participate in a new pioneering project, Evlogon, which above all aims not only to create new scientific knowledge, but also to build upon what has been already learned and achieved, as well as to define and apply good practices for the rehabilitation of emblematic monuments. Moreover, the diffusion and share of knowledge and promotion of the historical importance of monuments to the scientific community and to the general public are only some of our common values. So we're looking forward to this collaboration. I would like to close this communication by expressing our sincere thanks to the organizing committee for inviting us to this panel and to the welcoming moderator of the panel, Professor Yannis Liridis. Thank you.
Thank you very much for your short but to the point, presentation, a description of, in a few words, the most important issues of the archaeometry lab in your department. And I'm glad that this lab is going to survive, and not only, but to go onwards, something which Nikos would be very pleased to see from there that he is. And I thank you for your support, and I hope that the other colleagues in your department also will have will share the same views as you have it, and you share it with us. Next speaker is Christos Karapiperis from the DNA sequence company. Christos.
Thank you very much, Professor Liridis. Thank you very much, Professor Moropoulou, for the invitation. Okay. So my name is Christos Karapiperis. I'm a CTO at the DNA Sequence. DNA Sequence is a company that offers metagenomic service. For those that are not familiar with this term, metagenomics is the study of genetic material recovered directly from environmental samples such as air, soil, water, or building surface without need to culture organisms in the lab. The power of this technology is that with one analysis we can have all the microbiome of the sample. So it's very important and very powerful for our studies. I would like to share you the process of a metagenomic project. We start with sampling strategy and planning. This is very important because we must develop a strategy that is related with our hypothesis and the answers that we would like to have to our questions. The second one is the sampling process in the field. Then we have the laboratory part of the process, which is the library preparation, the extraction of DNA in the library preparation, and also the DNA sequence with the next generation sequencing machine. Then another important is the bioinformatic analysis that in this step we try to identify all the microorganisms. Another step in the bioinformatics analysis is the result interpretation. We not only need to know the microbes, we also need what they are doing. Then the reporting, and then we have the result evaluation and the future actions. And of course, we can start again all over the same process. As you see in this process, we have two key success factors. The first success factor is the lab. The lab is very important. In our company, our lab is certified with ISO 17025. It's the only lab in Greece that with this certification, and there are only few in Europe with this certification. But I need to clarify that this certification is for metagenomics analysis, because we can see some labs with this, but not for metagenomic certification. And the second one is for the second key success factor is the bioinformatics platform. We have 3 steps here. It's the primary analysis that we receive the raw data from the next generation sequencing machine. Then in this step, we identify the microorganism. Then we have the secondary analysis that we start with we make some statistics, evaluation, and also we enrich the data results with some secondary databases. And of course, the third step is the AI result interpretation that in our company we use agentic AI, specific AI models fine-tuned for metagenomics in cultural heritage. So it's very important for us, and it's a big accelerator for our insights. Some projects that were already done in the past, we work with the Department of National Gallery to identify the microbiota of some paintings. Also 2 excavations, one in Egypt and one in the Sphina Delphi with Professor Eligis. And of course, in the metagenomics analysis of the Holy Ejecule in Jerusalem with Professor Moropoulou. For this study, I would like to share some key findings. The samples that were collected for 21 different spots across the Holy Ejecule included wall, mortars, stones, for environmental DNA extraction and metagenomics analysis. Then, using a clustered beta diversity analysis, we identified 4 distinct microbial community profiles with clear spatial differentiation. As you can see here, there are the 4 dominant taxa. These 4 phyla are reported as the most prevalent in almost all samples, making up the core microbiota of the site. So, with this analysis, we are able to highlight specific microbial group known for stone and mortar degradation, including acid-producing and sulfur-oxidizing species. And of course, as we expected, there are some human-associated microbial taxa, specifically skin-related bacteria, were found in areas with intensive physical contact. So, with metagenomics in this study, we have microbial monitoring, and we believe that can serve as an early warning system for material degradation before visible damage occurs. Also, the presence of adapted microbial communities that might play a protective or neutral role, opening new questions about beneficial microbiota heritage sites. The purpose and the future application of this method could lead to spatial microbial risk maps, helping prioritize conservation efforts. And also the variation of microbial profiles in areas of high visitor contact reflect some usage patterns that we are able to prevent for some future problems that may occur because of this human activity. Why this is important? This is important not only for the result that I shared with you, but it's important because we help us to establish a biological baseline for each site, which this is enable us for comparison with future samples to track microbial shifts, supports predictive conservation models, climate change, increasing tourism. And also, this is very important for the long-term digital archives, including the Evlogon repository. And this is important for the when I go to Evlogon repository, this is important because it's a big challenge and an opportunity to try to integrate the metagenomics technologies with the well-established archaeometry technologies. And I think this will help us in order to have the microbial heritage fingerprinting and understand that it acts as a biological voice of monuments, turning preservation into multisensory dialogue across the centuries. Thank you very much.
Thank you, Nikos. Next speaker is Maria Merjani, Hellenic Ministry of Culture and Sports, Directorate of Conservation of Ancient and Modern Monuments, Director. Dear Maria.
Hello. Just before I start, I wanted to say that Nikos Zacharias has been a colleague for more than 20, maybe 25 years. And although other people who knew him much better have said a lot, I just wanted to say that Nikos was exceptional, but I think he was humble. And I think this characteristic of his personality has set an example for me, a professional example, but also a human example, as Vasilis Kilikoglu said. Well, today I would not be particularly exciting what I'm going to talk about, but I hope it is going to be useful, because our contribution to archaeometry is our connection with permission of giving permission to archaeometric analysis, to any analytical work. So our service is the issuing authority of sampling permits for movable monuments and the decorative elements of immovable monuments. So that means because the Hellenic Ministry of Culture is the exclusive safekeeper of archaeological material, there is the main legislation that refers to cultural heritage, the protection of cultural heritage, Law 3028 that has been updated, modified, codified in 2021, and there is a circular on the sampling of analysis of antiquities and cultural heritage in general. That's the legislation that covers the sampling and analysis permit. It is, I must say, it is a difficult procedure. It is a complicated procedure, but please don't be intimidated. For us that we live in our ministry bubble, we think it is straightforward. Maybe for you it isn't that simple, but it is. First, a researcher who wants to apply for a permit has to go to the local effort, to the regional service, put an application forward. Then it would either go to the Directorate of Prehistoric and Classical Antiquities or the Byzantine and post-Byzantine antiquities, according to whatever it is. And then with their opinion will come to us, and finally we will get to a sampling permit. We have worked all services that are dealing with this sampling procedure. We have tried to make it easy and straightforward to fill. And because it's so easy, we have also organized many seminars to tell you how it is all done, because it's not so easy, and we understand, but at least we are trying to get it out to make it simpler for users. And I must say that you can see that we have given out 1,039 sampling requests from 2018 to 2024. We also try to modify, if required, or to extend permits. And out of these applications, only 3 were rejected. So that means that what we are trying is to support research proposals, of course, under consideration of the legislation. And we are trying to respond quickly. So all the requests that we receive, we are trying to get them answered at least within 2 months, if sooner, if it is possible sooner. And you can see that regularly we have approximately 160, let's say, permits every year. Of course, during COVID, you can see the rate went lower. But of course, in 2022, when things were back to gear, we went up 2022 and 2023 with the high numbers. Of course, we are trying to make this procedure available from the National Register of Administrative Procedures. And as I said, because it's so easy, it does take us time. We've now trying for quite some time to put this procedure into Mythos, and we hope that soon we will get that explaining to researchers the steps and the decisions or the mid stages that a procedure will take. Other than that, our directorate is a service that implements a project. The last 5 years, we are participating in more than 60 projects. However, only 2 of them are related to pure research. One in collaboration with the National thank you very much, and where we worked on this nanobiomaterials for the sustainable protection of cultural heritage. And to the present, we are having another research project together with Demokritos on the monitoring of climate change impacts on monuments microenvironment, where we really try to get the results, all the results we got from the first project, to see if we can achieve to use innovative, sustainable, and sustainable materials that can help monuments to adapt to climate changes. Thank you very much.
Thank you, Maria, for the important work that you are doing in your department, in the ministry. I would like to invite Kalliopi Baika, Associate Professor from Aix-Marseille University, Center Camille Julien, Coordinator of the UNESCO Unit Win Network of Underwater Archaeology. Kalliopi.
Thank you very much for the invitation, Professor Moropoulou and Mr. Liridis. I would like to go to the underwater environment and speak about archaeometric approaches in coastal and underwater archaeology. We have been working since 2018 with Nikos in the framework of an interdisciplinary project, and he was the responsible for the archaeometric research. So actually, archaeometric approaches, and Nikos always have seen the laboratory of archaeometry with the laboratory of maritime archaeology as complementary, and that they should always work together. Applications of archaeometry in maritime archaeology is the principle. We cannot work without new state-of-art technology and digital tools for the location of underwater cultural heritage, the study, the monitoring, the protection, and the visual preservation. And I will go, of course, to the big challenges, the world challenges that we are all facing. And I think in this Congress we're going to talk about a lot, impacts of climate change. Speaking about the subject that Mr. Liridis and Mr. Karapiperis already talk about. Archaeogenetics is also part of the new horizons of the research, as DNA analysis have already started more than a decade ago in amphoras, ancient amphoras, in order to determine the content of the amphoras, but as well the preservation methods. And we have amphoras that were containing oil or wine, and the DNA analysis found preservations, for example, from oregano or mastic from Chios. Now, in the framework of an interdisciplinary project, a 10-year interdisciplinary project that has been under the aegis of the UNESCO Chair of Maritime Archaeology of Aix-Marseille University. This is where, in a very wide, complex harbor city, Aegina, many colleagues and teams we were brought together in order to see different orientations in studying. Study was one of the research is one of the objectives, but also training of the new generation of underwater archaeologists, archaeometrists, geologists, as well as dissemination and public outreach is one of our goals. So it's in Aegina, really in front of the modern settlement, that the ancient harbor city is very well preserved under the Acropolis of Apollo, the Temple of Apollon, and we are talking about an exceptional multifunction, sophisticated harbor system that has no parallel in the Mediterranean and the Greek world. So because of the unique preservation of the remains, the main objective is the landscape reconstruction. Therefore, as I said, more than 9 partners from 4 European countries, and it is the laboratory of archaeometry from the University of the Peloponnese that is responsible for all archaeometric analysis. Now, during all aspects of methodology, digital technologies and state-of-art techniques are part of our research, starting from 3D recording with total stations for the bathymetric and archaeometric recording of the underwater remains, the architectural documentation that is always complemented with 3D recording and reconstructions, underwater excavation and all the materials, of course, that we are excavating, and of course, photogrammetric documentation and 3D modeling on all aspects of the coastal and underwater research. Photogrammetric documentation always coupled with the architectural documentation, also for reasons for monitor of impacts of climate change, as well as monitor of marine growth, even after the covering with the geotextile of the ancient remains. Now, as I said, the archaeometric analysis, the responsible was Professor Zacharias, and we have been working with him with different materials, ceramic, but also metals from the underwater excavation, waterlogged wood, mortars, and stone, with permits from the Directorate during COVID. As you see, and one of the most exceptional results was that during analysis of mortars from the Byzantine coastal settlements, Nikos found that actually mortars contained ingredients that we can think about textile bleaching. So, in industrial coastal installation of the Byzantine period for this purpose. Now, other teams, of course, that were working in cooperation, all about archaeometric analysis, include marine geoscience, marine geophysical prospection by the University of Patras. Until now, we have done multi-beam and single sonar, side-scan sonar, and forthcoming is a sub-bottom profiler. Oceanographic prospection with ROVs from the National Kapodistrian University of Athens, and of course everything coupled with archaeological stratigraphy and the coastal geoscience, coastal geophysical prospections from Mainz, University of Mainz, including all techniques that you already know, but of course adapted in the underwater environment, ERTs, vibracoring, and electromagnetic induction. Finally, with the University of Calabria, we are trying a more holistic study of the harbor structures by application of numerical hydrodynamic modeling, part of different PhDs. And all, of course, are treated in comprehensive GIS databases. I want to finish with training, upskilling and reskilling in the state-of-art technologies, in these digital tools that we all need. We're talking about, we're working in the framework of a European project, and all of us, not only students, we need upskilling and reskilling towards all our lives. And this is something that is also very important for climate resilience. We need to educate, we need us to be updated in order to face the new challenges that underwater archaeology faces, natural and cultural environment, and this is, of course, impacts of climate change. Only from Aegina, we have the Acropolis that is actually falling, coastal erosion is accelerated all over the Mediterranean. We don't really have solutions, practical solutions to solve this very important issue, and hundreds of sites are lost per year all over the world. It's not only about natural hazards, but also anthropogenic impact, as during excavation we're exposing the sites and we have not actually found ways of real restoration when we are talking about sites on the waves. All these digital tools is about research, of course, it's about reconstructions, but also they can give us all the tools for the reconstructions to use for virtual and augmented realities. That means what we can use for public outreach, what we can give back to the local community, but also generally to the public. So all this information, we have compiled it in an application that you can scan with you can download on your mobiles or via QR scan. So this is how we would like to go on and continue on the steps, the legacy, the exceptional generosity, and the spirit of interdisciplinary cooperation of Nikos Zacharias. Thank you.
Thank you. Thank you very much, Kalliopi. Actually, you have referred, the last one later will be a report by Maria Kaparu, but you remind me years ago when I was the temporal committee of the department, when we started to establish, to install, this department with new staff, etc. And I felt a heavy overburden when, in my vision in those years, 2005, I think, and 6, when I set out to establish the laboratory of underwater archaeology and the archaeometry laboratory. The first teachers were Nikos and you, as you remember. I hope the continuity and support from the members of the departments will be strong and evident, because all the eyes, not only in Greece but also in Europe and the world, are set on the continuation of this laboratory. I don't want to say anything more, but I apply a lot. I apply many ideas, and I hope that the representative of the department, which is here and always present in these occasions of archaeometry, LNZME, will convey, this news to the department, that it is not only these two laboratories a matter of local interest, but it's a national, European, and world interest. Thank you. I would like to ask Maria Kaparu for make a report. She is a president of the Hellenic Society of Archaeometry, a report of today's panel. Maria.
This is actually, I'm just going to take some time to say some things that have to do with work we have been conducting with Nikos, and then I'm gonna report on the day. So, Nikos, before I start with Nikos, I would like to take the chance and thank the organizing committee for having us here, and Professor Tonia Moropoulou. So with Nikos, Nikos actually was my PhD supervisor. Back then I was starting my career in archaeometry, and I had started working on glass and vitreous material studies. And what I'm going to talk about today has exactly to do with a problem we had been facing during the course of my PhD. And I will actually talk about another aspect of this journey, which was object histories, small object histories actually, and more specifically of corroded surfaces, which to my thinking and to Nikos' thinking served as invisible testimonies. So if you look at the left-hand side of the slide, you'll see a corroded surface of what used to be a glass relief plaque. Who would say, I mean, it's really difficult to tell this was sometime in the past, something vibrant and lustrous and luminous probably. So and the question that emerges is, what if we could reconstruct an object's life story through its decay? Actually, when it comes to glass studies, a couple of things just to familiarize you with the concept is that glass, during glass degradation, there is an ion exchange occurring along with some environmental reactions, and these result in alkali depletion, a silica gel creation on top of the samples, and the visual manifestations we get are pretty much what you see here. And I think no one can deny that it's pretty tricky to say what is glass, what is faience, what is glazed steatite, or even what is stone, or even bone, because this is how they're misclassified in the archaeological record exactly because of the problem of corrosion. They might be small, but I was taught that they can say big stories. And despite being fragmented and altered and consequently overlooked, I had clearly in mind, and Nikos assisted over that, to understand in mind the question that these corroded objects could actually tell some really big stories. And this was a question, actually, if this microhistory that all objects carry, the biography they carry from the raw materials, from the moment the glass worker, in this case, acquires the raw materials, through the object's manufacture, the use, the object placement, in our case, the damage phase, the moisture / damage phase, and, if I may, the possibility of a likely ritual reuse of these corroded artifacts, towards the final burial and the modern excavation, where we actually get to have these corroded objects. What is it that we can get through these objects? And is there a biography that is behind these? And actually, by tracking surface changes and the chemical signatures of these objects, we do get so valuable information like how environmental conditions change over time, and questions that can be answered by healthy equivalents like the symbolic value of color and material, but in this case they're altered, but still they can give us similar information. And of course the movement and reuse of objects between both spaces or even functions. So the idea is that even the most degraded objects, like the one you see on the right-hand side of the presentation, are indeed objects that can give us information on the object's life, on the people who interacted with it. And I have a good example here of what used to be an almond-shaped bead. Now we have a faint idea of its initial form. The decoration is not there, the color is not there. So this specific sample was actually deemed in the archaeological record as glass. So what we did was actually apply a set of different techniques. In this case, the example I have for you is a macro XRF technique. And what we managed to see is that actually we have the coexistence of silicon with potash, which suggests the existence of a glaze. We also have some pools of copper, where copper rules, we can see that silicon vanishes. We have some spots of manganese, and all this, along with other microscopic examination and a lot of studying, led us to decide that this specific object is made of ions, and it actually was probably in its early life. Its elemental composition shows that it is representative of the Eastern Mediterranean faience industry, likely filtered by Cypriot and Cretan intermediaries. And whether it was crafted locally or not, it indeed embodies the participation of the Mycenaeans in the world of meanings, in the world of making and the world of materials, despite its corroded nature. And this is another example of another degraded material. Again, this used to be deep blue, this set of materials. Now what we've got is its total discoloration, the creation of a patina. So with the application of the different setups of X-rays, we managed to see the initial color, the technological choice of the maker, which was a combination of cobalt and copper in this case, which is obviously related to aesthetic, to rituals, to everyday decisions. But also we get the chance to have a second story, the evolution of the color after burial, after the corrosion process started. So we have a dual history here. I don't want to tire you more with this. This was the idea spanning my research, having been spanning my research recently. And that's why, along with my colleague Artemios Economou, within the framework of the third call for postdoctoral researchers by Zacharias, we decided to compile a handbook having practical guidelines towards the classification of these materials, with the idea in mind to being able to classify them and then make them tell a story. Because if there is a takeaway from these presentations, exactly that when we read corrosion not as damage, but as a testimony, small artifacts, in this case glass artifacts, can transform into storytellers. And because I don't want to monopolize anymore, or I will in any case, I would just like to say a few things about Nikos, whose work has contributed undoubtedly to shaping the field of archaeometry. Nikos also believed in surfaces as testimonies, and he used artifacts as storytellers. So I think his legacy lives in the questions we ask and the methods we use to read the past. So, representing the Hellenic Society for Archaeometry Board, I would like to let you know, in case you don't know, that we have launched a special volume in memory of Nikos. And we welcome contributions from the fields Nick has excelled at. If you want to find out more information, if you want to contribute or support this volume, you can either visit our site or email us or follow us on our channel, whatever you wish, and we will be more than happy to let you know on what you can do to help. Thank you.
Thank you. Thank you very much. Now we're closing the interesting panel, and I would like to invite the host, Tonia Moropoulou, if she would like to say any word and to close also this session.
Thank you, Yannis. Thank you, all of you, for coming here, for your contributions to a perspective which is promising, which will always commemorate the initiator, Nikos Zacharias, our friend. And I believe that through Evlogon, we will be capable to articulate and merge our capabilities, and we will go on. His legacy will survive. Thank you very much. Thank you.